Hello everyone. In this recording we're going to go through some of the homework for Chapter 10. Okay, so in this problem, the first one, we are going to take a look at some information given to us, certain costs for an organization. And you can see out here on the right hand side, I'm circling it, we're given our data table. We have 12 months worth of data, and the author is giving us maintenance costs, health insurance, and shipping costs. Okay, and the first requirement that the author is asking us for is we have these three different costs: maintenance cost, health insurance, and shipping costs. And we need to decide what type of cost it is. Remember, there are three types of costs. We have fixed costs, we have variable costs, and then we have costs that are both fixed and variable together, and that would be called a mixed cost. So this is how you figure it out. So first I'm going to take a look at health insurance as an example. If I see January, February, March, April, I go all the way down the line. Do you see that the total cost is exactly the same regardless of activity? And the cost driver here would be the number of employees. Even though the number of employees are changing, the health insurance costs are exactly the same. That's an example of a fixed cost. So over here in the homework problem on the left-hand side, we're going to say health insurance is a fixed cost. Now, how about shipping costs? So you can see the shipping costs, January, February, March, April, May, June, July. You can see the totals change. Because the totals change, we can rule out that they're fixed costs, because it violates the whole idea of a fixed cost. It's the same in total regardless of activity. So the second thing we're going to do is to test to see if it's a variable cost. If it's a variable cost, we're going to see that the variable cost per cost driver is exactly the same. So the cost driver for shipping costs are units shipped, which is the last column. So let me test. January, $21,948 divided by 7,080 items shipped. That's $3.10 per item. I'm going to do the same thing with February. 25,451 divided by 8,210. I get the same $3.02 per unit. 24,521. I'm working on March. Divided by 7,910 units shipped. Wow, I get the same $3.10 per unit. I will not bore you and do this 12 times, but trust me, if I did do it 12 times, January through December, I'm going to get the same $3.10 per unit shipped. That means that the shipping cost is a variable cost. And once again, the cost behavior of a variable cost is the totals will change as activities change, but the per unit amount remains the same, which is the case here. And the last cost that we did not work on is maintenance costs. So let's first test to see if it's a fixed cost. We can see January's total is different than February's total, is different than March's total. So we can rule out that it's a fixed cost. It's not. If it was a fixed cost, these totals would be the same. So now let's test to see if it's a variable cost. So what we will do is we will take the total. Let's take January. The total is $4,480. And I will divide it by the cost driver, which in this case is 159 machine hours. That works out to $28.17 per machine hour. Let's see if February is the same. 43.61 divided by 110. That's $39.65. They're different. So it's definitely not a fixed cost. It's definitely not a variable cost. That must mean it's the last item, which is a mixed cost. Once again, mixed is partly variable and partly fixed. The next part of the problem is asking to use the high-low method. We are going to actually figure out our fixed piece to the maintenance costs. Okay, before we do that, let's take a look at the cost formulas. So we said earlier a maintenance cost is mixed. So the cost formula, the formula for a mixed cost is this. Y, which represents the total costs, equals, and remember mixed are partly fixed and partly variable. A represents the fixed cost plus B represents the variable cost per unit and X represents the number of units. Health insurance we said was a fixed cost. Therefore, Y, which is the total cost, will equal the fixed cost. Shipping cost is variable. So we'll say Y, which is the fixed cost, equals the variable cost per unit times the number of units. So those are our formulas, our cost formulas. So now that we know our cost formulas, let's do our cost functions. So we said maintenance. Maintenance was mixed. We said maintenance was mixed. Here's our cost formula. Y, which is the total cost, equals the fixed cost plus the variable cost per unit. Okay. So, how do we get the $4,130? How do we get the $2.10 per unit? What we're going to do is we are going to use our method called a high-low method. And basically what the high-low method is all about, the high-low method is it's a method to try to estimate with a mixed cost the fixed piece as well as the variable cost per unit. And what you're going to do is you're going to take a look at all of the data that we're trying to analyze. You are going to take the high point in the cost driver. So if I take a look at the cost driver, which are machine hours, the high point is November, where we had 520 machine hours. The low point is right here, 110. That's February. Okay, and then with the high-low method, we're going to take the high cost driver minus the low cost driver, 520 minus 110, and the difference is 410. We will also look at the dollar amounts attached to the high level and the low level. So the high level, where we had 520 machine hours, we had a total cost of $5,222. And at the low level, where we had 110 machine hours, the maintenance cost was $4,361. If I subtract the high from the low, I get $861. And so to figure out the variable cost per unit, we will take the change in the dollars, which is 861, and we will divide it by the change in the number of units in the cost driver, in this case machine hours. If I take 861, excuse me, divided by 410, I get $2.10 per machine hour. That is the variable cost per unit. So, if I take my cost formula, and at the high level, the total cost was $5,222. So the total cost, $5,222, minus the variable cost per unit, $2.10, times 520 machine hours. The result will be the fixed cost, which happens to be $4,130. I can also test it at the low level. The total cost was $4,361. So total cost minus variable cost per unit, which we said was 210, times the number of units, in this case machine hours, 110, you get the same 4,130. So we have concluded that the cost formula for maintenance is total cost Y equals the fixed cost piece, 4,130, which we calculated using the high-low method, plus $2.10 per machine hour. That is, once again, we calculated that using the high-low method. The health insurance was fixed. So we see the health insurance is $8,660 across the board. And the shipping cost we said was variable. And if you recall earlier, we did that math. And if we checked every single month, we checked the first 3, I believe. But I told you to trust me. And if you test it for all 12 months, you get the same $3.10 per unit. That means it is a pure variable cost. So when we take our three costs together, our maintenance, which is mixed, our health insurance, which is totally fixed, and our shipping cost, which is totally variable, if we add up, if we did the entire organization with these three costs, Y, which is the total cost, equals the fixed cost. If you take the $4,130 and the $8,660, we'll get $12,790 plus $210 per machine hour plus $310 per unit shipped. These are the two variable costs. And the last requirement, basically, the author says, what if we have a month where we're budgeting for 480 machine hours, 100 employees, and 9,200 units shipped? Well, if we do the math and we use our formula, this will equal the total fixed, which we said was $12,790 plus we have two variable costs, $2.10 per machine hour for estimating 480 machine hours plus $3.10, and we are estimating 9,200 units shipped. If you do the math, $42,318 is our monthly operating cost in this what-if scenario. All right, so this is using the high-low method. This is a good way to try to figure out a mixed cost, breaking it up between the fixed cost piece and the variable cost per unit piece. And this is a good way to budget in the future whenever we have mixed indirect costs. In this next homework problem, once again using the high-low method to estimate our costs and go forward, in the future, trying to come up with a budget number. Here we have a helicopter service from suburban towns to JFK Airport, New York City. This particular helicopter service has 8 helicopters in their fleet. Each helicopter makes between 900 and 1,800 round trips a year. The records indicate that a helicopter that has made 900 round trips in a year incurs an average operating cost of $385 per round trip, and one that has 1,800 round trips incurs an average operating cost of $250 per round trip. And so what we're going to do is use the high-low method to try to break up these costs between their fixed piece and their variable piece. And once again, what you're going to do is you're going to take the cost driver at the high level, which is 1,800 round trips, minus at the low level 900 round trips. The difference is 900 round trips. And now we're going to take the total dollars. So at the high level, we said 1,800 round trips. The author told us our average cost at the 1,800 level is $250. If I take 1,800 times 250, so my total operating cost at the high level is $450,000. At the low level, 900 round trips times 385, or $346,500. The difference between the high of $450,000 and the low of $346,500 equals $103,500. If I take that $103,500 divided by 900, I get the variable piece, which happens to be $115 per round trip. Now that I know the variable piece per unit, I can test it by doing either the high or the low. Let's take the high. If the total cost is $450,000, okay, total cost of $450,000 minus the variable cost. We know the variable cost per unit is $115 times the number of round trips, which at the high level is 1,800. So $450,000 total cost minus the variable cost, $115 per round trip, times 1,800 round trips will equal $243,000. You can do the same thing at the low level, and you can plug in the $115 per round trip, And guess what? You're going to get the same answer, 243,000. So our formula, y, which is the total cost, equals the fixed cost, which is 243,000, plus variable cost per unit, $115 per round trip. Okay, and let me just go through the last question. It says, if this travel company expects each helicopter, and remember we have 8 helicopters, there are 8 helicopters in the fleet. If each helicopter on average makes 1,300 round trips in the coming year, what will be the estimated operating budget? Well, we're going to use our formula. So the total cost, y, equals the fixed costs. Remember, fixed cost is the same, $243,000 regardless of activity. All right, so y, total cost, equals fixed cost, $243,000, plus variable cost per unit, $115, times the number of round trips, which we said is 1,300 in our example. That works out to $392,500 per helicopter. And if there are 8 helicopters in the fleet, the answer will be $3,140,000. That will be the estimated budget if these were the scenarios. In this next homework problem, we have a company, and you can see the data table. We have a company here. They have their total costs, and we know the costs they're not fixed and they're definitely not variable. So we have a bunch of mixed costs here. The cost driver, the number of hours, and so the author is asking us, what is the variable cost per unit? And so one of the ways to estimate the variable cost per unit is to take, out of the data given, to take the highest cost driver, which in the data given, the highest cost driver is May, 6,300 hours. And we're going to take the low level, out of the information given, the lowest level is February of 3,300 hours. So if we take the high minus the low and the number of hours, 6,300 minus 3,300, the difference is 3,000. And so what we will do is we are going to take the total cost, 75,800 for the high level, and the low level is 39,800. So the difference between those two, 75,800 minus 39,800, the difference is $36,000. And we will divide that by the change, the difference between the high and low level for the cost driver, which we said was $3,000. That's where I get my 12. 12 represents the variable cost per unit. Now the second requirement is asking for the constant. The constant is the fixed cost. So the slope coefficient is the variable cost per unit. The constant is the fixed cost. And so now that we know the variable cost per unit is $12 per unit, let's take the high level as an example. If I know I have 6,300 hours, so let me do 6,300, and I know that my variable cost is $12 per hour, so 6,300 times 12, that gives you 75,600. So if the variable cost is 75,600 at this level, and the total is 75,800, the difference is $200. That will be the fixed cost. Okay? You could do the same thing for the low level. You're going to get the same answer, which is 200. So our cost formula is y equals the total cost equals the fixed cost is $200 plus the variable cost per unit, $12 per unit. So in requirement D, it's saying, what if we're budgeting for 3,600 hours? Well, you will simply take your $12 per hour times 3,600. That works out to 43,200 plus your fixed cost of 200. There is your $43,400 is your answer. Next homework problem, very similar, using the high-low method. We have a whole bunch of activity levels, And from the activity levels, we're going to take the highest cost driver, highest level with the highest cost driver, and the lowest level. 4,700 is the high, where there's a cost of 54,400. The lowest level is 2,100 units at a total cost of 31,000. So the difference between the high and the low, dollar-wise, is 23,400 divided by the difference of the high and low level in cost driver, or 2,600. 23,400 divided by 2,600 gives you a variable cost, which is $9 per unit. And now that we know the variable piece, we can now figure out the fixed piece. We will test it by using the high level, where the total cost is 54,400 minus the variable cost is 4,700 units times $9 per unit. That works out to 12,100 is your fixed cost. So if we are producing 2,500 units, we will say the total cost for 2,500 units equals the fixed piece, which is 12,100, which we just figured out, plus the variable piece, $9 per unit times 2,500 units. Answer, 34,600. Answer is C. In this last homework problem, we have a company here where they're trying to figure out how many units they need to sell in order to make a certain amount of profit. And so the information given to us is we make one product, we know our total fixed costs are $210,000, and we know that the variable costs are $11 per unit. So we don't need to figure out our fixed costs and our variable costs. That's already figured out. What we need to know is we know our selling price is $19 per unit, and here is the what-if scenario. We want to make a $630,000 profit. And so what we're going to do is we're going to use the formula, and hopefully this makes sense to everyone. The formula is selling price per unit times the number of units minus all of our costs, and our costs are our fixed costs plus our variable cost per unit times the number of units equals profit. And so let's just fill in the blanks. We know our selling price per unit is $19 times the number of units we need to sell, minus, and our fixed costs are $210,000, plus variable cost per unit, 11 times X, the number of units, equals profit, 630,000. So if we solve for X using a little algebra, we get 19X minus 11X, and we'll take the 210,000, add it to the other side, solve for X. 105,000 units will need to be sold in order to make that profit. And this is something very important. If that's in our budget and that's in our plans that we want to make that profit, we know what the goal is, how many units we need to sell in order to get to that profit level.